In this video, we're going to be talking about using linear equations to model data. We find that a lot of times in real life, we can represent the data that we have with an equation that is linear. For example, this first one says, a wrestler decides to go on a diet to lose weight. He started at 180 pounds and lost weight at a constant rate. After 8 weeks, he weighed 164 pounds. Let W of t denote the wrestler's weight, measured in pounds, as a function of time, measured in weeks. Write a linear equation in the form W of t equals m times t plus b to represent this data. So first, to start, we notice from this equation that t is the input. So t is going to be the same thing as x in a coordinate. So time will be our x coordinate. And W of t, that's the output, is going to be the same thing as y. So we're going to label that as our y coordinate as weight. A lot of times I have students ask me, how do I know which one is x and which one is y, which one's input, which one's output? And they're telling us here in the way that this equation is written. So the t here is the same thing as our x, W of t is the same thing as our y. So now that I know the ordered pairs are going to go TW, or time weight, I can use the information I have to make some ordered pairs. The first one says he started at 180 pounds. So at week 0, so when he first started, before any weight loss had occurred, week 0, he weighed 180 pounds. Then after 8 weeks, so since time is measured in weeks, the second ordered pair is 8 for time. He weighed 164 pounds. Now this problem is just like all the other problems that we've done in previous videos. I have 2 points and I want to make a linear equation. So to make a linear equation, I'm going to need 2 things. I'm going to need the slope and I'm going to need the y-intercept, because they tell us they want our answer in this form, slope-intercept form. First thing I have to do is start with slope. Slope is the same thing as y2, so 164 minus y1 over x2 minus x1. 164 minus 180, I'm subtracting more than I have, so I'm going to end up negative 16. 8 minus nothing is still 8. And my slope is negative 2. So now that I have a slope and a point, or a couple of points, I can write a linear equation. In fact, this point happens to be the y-intercept. I don't have to do any work to find that. Since it's in the form 0 and then a value, this is going to be on the y-axis. So I know my b, or my y-intercept, is 180. If you've forgotten how to identify that, I would suggest going back and watching the video on writing linear equations. But for this problem, we want to write it in this form. So now that I have my slope, I have my y-intercept, I can fill in what I need. W of t equals our slope, which is negative 2. T is our variable, plus our b, our y-intercept, of 180. And there you have it. Go ahead and try the next example. Alright, let's see how you did. The next one says, an ice cream truck owner noticed that there was a linear relationship between the temperature outside T and the amount he made in sales, S. Data showed that if the temperature was 58 degrees outside, he made $200 in sales. When the temperature was 72 degrees Fahrenheit outside, he made $592 in sales. Write a linear equation in the form S equals mt plus b to represent this data. So again, we need to define what our x and y, our inputs and outputs are. Looking at this equation here, it's in slope-intercept form. T is the same thing as my x value, so temperature, not time, in this example we're talking about T for temperature, is going to be my x value, and then S is going to be the output, so sales or the money is the output. Alright, so now that we know what the ordered pairs, the x and y are, we can go ahead and make some data points. First said when it was 58 degrees, so that's my x value, 58, he made $200, that's my y. Then another day, it was 72 degrees outside, and he made $592. So there's my 2 points, and now that I have 2 points, I can write a linear equation. I need to find my slope first. y2 minus y1 divided by x2 minus x1. 592 minus 200 is 392, and 72 minus 58 is going to be 14. And then when I go to simplify, 392 divided by 14 is 28. So my slope here is 28. Now neither one of these is the y-intercept because they're not in the form 0 and then a y value. They both have a different x value other than 0. So I need to find my y value. My y-intercept here. So I could either use point-slope form or slope-intercept form. Because I want it to end up in this slope-intercept form, I'm just going to go ahead and use slope-intercept to find b. I'm going to plug in one of these two values for x and y. So I'm going to go ahead and just use the first one because they're smaller. And I'm going to replace S, the sales, with $200. My slope is 28. And temperature was 58. I need to find B. So I have 200 equals 28 times 58 is 1,624. And then 1,624, I need to get rid of that to get B alone. I end up with a negative 1,424. Again, you could have used the point slope form as well to plug in these values and then get the S value alone, but I chose the slope-intercept way. So now the final answer is S equals, my slope was 28, and T for temperature still, minus our y-intercept was negative, 1424. And there you go. There's our linear equation. Let's look at some more examples, different types. The next two examples are going to be in this form, talking about total cost of something. In general, there's what we call a fixed cost, meaning no matter how many miles you go or how many classes you take, you still have to pay this fixed cost either way. And then there's a variable cost, meaning it's a certain amount that you have to pay per item. So, and then for each item you have to pay that amount. This first example says, Tom and Karen rented a small truck to move their furniture to their new apartment. The rental agency charged $80 upfront for the truck. So that's just the cost you have to pay to get the truck. And 45 cents per mile. So that's going to be the variable cost. Each mile they drive, they have to pay 45 cents. Part A says, find a linear equation to represent the total cost C after driving M miles. So on this example, we are going to have C for our total cost, and we have to pay per mile So the cost per mile is 45 cents times the number of miles, and they want us to use M for miles, plus that fixed cost. I have to pay $80 no matter what. And there's my equation. Now, on part B, it says if the total cost was $188, how far did they drive the rental? So the cost was $188. Now I'm plugging $188 in for C. I know the cost. I don't know the number of miles. That's still a variable. Anything I don't know, I leave as a variable. I want to get M alone. So first I have to subtract 80 from both sides of my equation. I now have 108 equals 0.45 M. I need to undo this multiplication with division. So I divide both sides of the equation by the 0.45. And I end up with 240 for M. And that represented M was in miles. So I'm going to include my units there. So they drove 240 miles and it cost them $188. On part C, it says how much would it cost for them to drive 350 miles? So that's what we have to find. We have to find cost now. So I don't know C. It's still 45 cents per mile, and they are driving 350 miles. So now I do know M. I use order of operations to simplify. 45 cents times 350 is 157.50. I add on my 80, and I end up with the cost being $237.50. Alright, we have one more example here. This last example says a local gym charges $19 a month plus $3 per Zumba class. Find a linear equation to represent the total cost of a 1-month membership C after attending N number of Zumba classes. So this again is going to be in that fixed cost plus variable cost form. So the total cost will be the variable cost, which is for each Zumba class I take, I have to pay $3. So I have to pay $3 times the number of classes that I take, plus that fixed cost of $19 a month. There's my linear equation. Part B says if the cost of 1 month was $43, how many classes did the member take that month? So now we know the cost was $43, so we're replacing C with 43. We don't know the number of Zumba classes. I want to find N, so I have to get rid of the 19, the constant from both sides. Subtract that away. 43 minus 19 is 24. Just bringing this up here. And then lastly, dividing by 3 and getting 8. So they took 8 Zumba classes. Part C asks, how much would it cost for the member to take 15 classes? So we know they're taking 15 classes. We know N is 15. We don't know the cost. So we leave C as a variable, replace N with 15, and we still have that fixed cost of $19. So now 3 times 15 is going to be 45. Plus that 19, and we end up with it costing $64 And there you have it. Good luck on your homework.